Here. Welcome to Knowledge Nourish. Let's check how the behavior of computation is being done at compile time or whether it's at runtime. So far we know, okay, we do have literals, we do have variables, they have their own behaviors. Literals are behavior is command at compile time. But the question was, how do I know if this is done at compile time or runtime? So we know one thing for sure at compile time we do know there is an artifact called dot class file is get generated. We obviously know it's by its own magic code. It's a byte code that gets interpreted by the corresponding runtime, which is the Java. So let's check where does this file is created. So we are in this directory, and if I see, go to bin, go to the main, go to Java week 1 fun with primitive class. So we do find our class to be available there. So now if I just say, okay, can I open this file? Okay, it can't be open at console level. Let's just get it. So there is some gibberish text that we might not understand. It's able to, it should be interpreted by the compiler itself, right? The interpreter. So is there a way I could read this file? So many of you are already aware, like there is a utility called java p. Java p is nothing but Java's internal decompiler. It's a utility from Java itself, so you can use that and decrypt the content back in a readable format so that we can understand, okay, what's going inside that file. So let's go into this file. We'll say java p, and we want to go to the primitives class. Okay, so this is the compiled version, and java p will decompile it back and it gives you back the corresponding source code for it. So you see in our code we have defined the variable int e is equal to 10 into 25, but here if you look at the whole file, our main function got start, it's create some variable storing some constants. So we do have defined some literals there, right? 5, 10, so all those will get stored. So after that, if you see, do we see a 250 there? Because that's what we are interested in, right? So 10 into 25 is 250. Okay, yeah, we see a 250 there. We don't see any operation being done or any list of operations that are being to be computed at interpretation. So it's done at compile time itself. It doesn't store it as 10 into 25 or any some sort of operation like I have to do addition, load this variable, load that variable. It's nothing like that. It's directly stored there. So just for the clarification, let's maybe make it 205 so that we should see 2050 at this time. So yeah, so we do see 2050 is being pushed there, so that means it's not at runtime. The compiled artifact itself shows the computation was done and it get pre-compiled, pre-computed, and the interpreter will just take that value. So it's a push and it will store into the memory location wherever, and it will read that value 2050 and it will print it to the console. So it's really happening at compile time. So that's the proof for that. We went inside the dot class file, we decompile it using the java p command, and we know 2050 is the literal that get pushed into its own internal semantics. Let's check how does it behave for slash operator, the division operation. So this time we see, okay, there's a 0 is behind the scenes, so let's give some meaningful value. Let's say 210, so we should see 20. Yep, so it's saying push 20. Now let's see how the behavior is done for if I just replace it with 0. Will it compute it? But it can't compute it, right? We saw it was an arithmetic error. Let's see what's happening behind the scenes. Okay, so now we see this time it's not just 20. This time we see another variable as well. Okay, push 200, push a constant 0, and then perform the division operation. So which means this division by 0 is not computed at compile time. Division by any other operator, the denominator apart from 0 will be computed at compile time, because this is really an issue when we get to know when we run the program, right? Okay, we'll get to know, okay, we cannot divide it by 0. So it might have done it internally itself and thrown that error, but that's how it handled nicely at the bytecode level. So it will load the variable 200, load the second variable 0, perform the division, and then store back the results. So, and at that time when it tried to actually run it, it lands into an error which is arithmetic error, and it's a runtime exception. Only at runtime we get to know. So for the division case, just for the specific division case when the denominator is 0, it's a runtime action. Let's just confirm it again. So we should not see 210, we just directly see 20. Yeah, it's exactly 20. We don't see any division, I division or other operators. So similarly, that's what I was saying for this multiplication as well. It should be directly 2000. It should not be load 200, load the constant 10, I multiply. There's nothing sort of that. It's always going to be 2000, so it's pre-computed. So that's what really compile time means. So tell me in the comments, like, what should do you think the output or the behavior for this will be? What do you expect the output for this? Thank you. We'll see. We'll meet next time.